So what did we learn about exploration, Charles?
Well, we actually learned a lot, but really I think you can summarize in just a couple of things. We learned about bandits,
Okay.
which is really all about stochasticity and randomness. And in particular, we learned about how we can estimate what we know using Hufting bounds and maybe some union bounds.
So, yeah, in particular, we employed Hufting bound, union bound to convince ourselves that we have a sufficiently accurate estimate that we can get near optimal reward in these kind of non-sequential but stochastic decision problems.
Right, and that's really important because a lot of the time you don't know what to do because you're not certain or how certain you really are about what you know. And what the Hufting and union bounds tell us is how certain we really are, and so we can know when we're certain enough.
Good. All right, so we have a stochastic world. We want to learn how it works so that we can get near optimal reward, so we can optimize.
Right. So that was the first thing. And then the second thing is we learned about Armax, really, and how Armax works specifically with deterministic MDPs.
Right, and so that was about optimism in the face of uncertainty and how it would cause us to explore or discover new stuff about the world kind of by planning ahead and trying to get to states where new information could be gained.
Right. Well, what it really says, it's really, we believe the grass is always greener until we get there and learn otherwise.
All right, great. This let us deal with sequential decision-making. This let us deal with stochastic decision-making.
And then we combine them.
Right, where we used the bandit idea to estimate the noisy parameters, the transition probabilities and so forth. And we used the Armax idea to make sure that we visited things enough so that we could get those accurate estimates.
Right. So Armax still basically remained Armax. And the bandit stuff helped us with the transition probabilities so that we knew when we actually believed them. So they were kind of, this isn't really true, but they were kind of deterministic enough. So we knew enough to know what the transition model is. And once you know what the transition model is, you can just kind of go from there. Because then you can just estimate the rewards and do the right thing.
Now, this notion of the way that learning happens in the bandit here, where we actually kind of distinguish between known and unknown, can actually be generalized even beyond the kind of general MDPs that we're talking about here. And I don't think we're going to get a chance to talk about this, but the idea of quick learning is learning transition probabilities using methods that know what they know. And if it can distinguish between known and unknown, it can associate optimism with the unknown, and then we can make guarantees on how quickly and efficiently near optimal behavior can be learned.
Nice.
So this is kind of a learning framework that my students and I have been studying to try to generalize beyond learning in tabular MDPs to be able to generalize between transition probabilities in different parts of the MDP.
Well, that all makes sense to me. So then the only question is, how does this help us do practical reinforcement learning?
All right, so that pretty much ends this. Well, so just briefly, I find that Armax is actually a really effective algorithm to use in practice. We don't set that parameter of how often we need to see things to be what the theory says we should set it to. We usually set it to something much, much smaller than that. And we try to, by hand, strike a trade-off between making it too small, in which case it might actually not learn near optimal behavior, and making it too big, in which case the learner actually has to sniff around and visit many state action pairs over and over again. So Armax itself does seem to be a pretty effective algorithm. It makes very good use of the data. It's just we can't quite use it in the theoretically specified way.
Okay, well, that's good enough for me. Seems pretty practical. Okay, so we're done. So are we done with the class? What's next?
We have more stuff. We have what's next.
Oh, cool. Well, I look forward to that.